Hello everyone, welcome back to STEM Aerokobe Academic channel. I am Haftom Aragawi, lecturer in Electrical and Computer Engineering. In our previous lecture, we learned about the history and evolution of C++ programming language. We explored how C++ grew from a small project in the late 1970s into one of the most powerful programming languages used today in different game engines, operating systems, finance, artificial intelligence, and in designing different embedded systems, right? We also covered how C++ began as C with classes, early features that made C++ programming language different from C programming language, templates and the standard template libraries that transform the language, major versions like C++ 98, C++ 03, C++ 11, C++ 14, C++ 17, C++ 20, and 23, right? Why C++ is still popular, even with many new languages around, right? The features of C++ with continuous updates and improvements. Overall, we saw how C++ has evolved for more than 40 years, while staying extremely fast, powerful, and relevant for modern software developments, right? In today's lecture, we are taking our first step into the world of programming by exploring why programming is important, how computer systems work, and what makes up a program. Besides, we will look at the difference between hardware and software. We will understand what programming languages are, and we will learn the basic structures every program flows through input, processing, and output. We will also walk through the programming process from planning to testing and introduce the two major programming approaches, such as procedural programming language and object-oriented programming language, right? Therefore, this lesson will give you a clear foundation for writing your own programs, right? Here is what we will cover today. In Why Program, we will talk about why programming matters, how program helps us to solve problems, to automate tasks, to build applications, and to create technologies that can shape our everyday lives, right? In computer systems, we will learn the difference between the physical parts of a computer and the software that runs on it. In programs and programming language, we will look at what programs really are and how languages like C++ programming language allows us to communicate instructions to the computer. We will see what is a program made of. Before building programs, everybody should understand the building blocks a program like keywords, variables, operators, statements, and structures, right? We will see the core of any program, namely input, processing, and output. That is, we will see how data goes into the program, how the computer processes it, and how useful results came out, right? In programming process, we will break down the steps of solving problems with code. That is from planning and writing the program to testing and debugging, right? Finally, we will compare the two major styles of programming, such as procedural programming, which focuses on step-by-step instructions, and object-oriented programming, which organizes code into objects and classes, right? By the end of this lesson, we will have a solid understanding about the computer systems and on how to write the program, right? A program is a step-by-step instruction for the computer to perform a specific task. It is the bridge between human ideas and computer actions. Simply, a program is like a recipe which gives step-by-step instructions that the computer follows to get a desired result, right? For example, we can develop a calculator application that adds or multiplies a number, or we can develop a web browser that loads a website, right? When we see a programming, simply programming is the process of writing instructions that a computer can understand and execute. These instructions are written using specific programming languages, such as either Python or C++ or Java and other programming languages, right? Through programming, we tell a computer what to do, how to do it, and when to do it, right? So the programming involves designing of an algorithms, writing of a code in a programming language, testing and debugging, executing the program to solve real-world problems, right? In simple terms, programming is telling the computer how to perform tasks through a code, right? Or it allows us to solve problems, to automate works, and to create new technologies, right? A programmer is simply a software developer, right? So we can say a programmer is someone who teaches the computer how to think and act, right? They use programming languages like Python, C++, Java, MATLAB, and so on, right? To create softwares that solve real-world problems, right? His or her main responsibilities are writing code, which is a program, debugging and testing errors, designing an algorithms, and maintaining and improving the software, right? As we have discussed in previous slide, programming is the process of giving instruction to a computer to perform a specific tasks, right? So we need a program to solve problems, which is the programming helps us express logical solutions for real-world problems. That is from calculating bills to predicting diseases or managing traffic, right? We need a program to automate tasks. That is, instead of doing repetitive work manually, we can write a program once and let the computer do it thousands of times, which is faster and without mistakes, right? We need a program to build applications and systems. All modern applications, like websites, games, robots, and machines are powered by programs, right? So programming lets you create these technologies. We need a program to think logical. We need a program to think logically and creativity, right? Which is the programming helps us to improve problem solving, analytical thinking, and creativity. Therefore, programming skills are useful in any field, right? We need a program to control hardware and data. That is from sensors in Internet of Things, devices to satellites in space. Programming is used to control hardware and analyze data effectively. We need a program to empower innovation and career. That is, programming opens doors to careers in artificial intelligence, software development, data science, robotics, and more, right? In short, we program to make computers work for us. That is to solve problems, to save time, to create new technologies, and to build the future, right? Basically, computer system is a combination of hardware and software. Hardware provides the physical components, while software provides the instructions that tells the hardware what to do. However, before we discuss the detailed difference between hardware and software, it's better to know about a computer. What is a computer? Why we need computer? What are the key features of a computer? So, a computer is an electronic device that can receive data, which is input, process it according to instructions, and produce meaningful information output, right? So its key features are perform tasks automatically through the instructions, process data using hardware and software, can store large amount of information, works faster and more accurately than humans, right? For example, when you type a document, the computer receives your keystroke from the keyboard, which is input, process them, and display text on the screen, which is an output, right? As we have seen in previous slide, hardware refers to the physical parts of a computer system. That is the components you can see and touch, right? So basically, a computer hardware has 5 major components, such as input devices, which are used to enter data, output devices, which are used to display the processed data, secondary storage, which are used to store data permanently, main memory, which are used to store data temporarily, and the central processing unit, which is used to control every activities of the computer, right? So central processing unit is the brain of the computer, which is responsible for executing instructions from programs and controlling all operations of the computer system, right? Therefore, it is the main processing components of a computer that performs all the calculations, logical operations, decision making needed to run a programs, right? It works closely with the main memory and input-output devices to make the computer functional, right? Internally, central processing unit consists of 2 main parts, such as control unit and arithmetic logic unit, right? The control unit coordinates all of the computer's operations. It is responsible for determining where to get the next instruction and regulating the other major components of the computer with control signals, right? The arithmetic and logic unit, as its name suggests, is designed to perform mathematical operations, right? Therefore, central processing unit is controlling every activity of the computer with the help of control unit, and performs every arithmetical and logical operations with the help of arithmetic logic unit, right? This is the central processing unit's role in running a program. Every program is made of instructions stored in a memory, right? The central processing unit runs these instructions through a process known as the fetch, decode, and execute cycle. Fetch cycle, the control unit gets or fetches the next instruction from the main memory. In decoding cycle, the control unit decodes or interprets the fetched instruction. That is, it determines what action to perform. It identifies if it's an arithmetic operation or data transfer or control command, right? In execute cycle, the arithmetic logic unit performs the required operations. It may be an addition or comparison or relational, right? Then the executed result is stored in a register or sent back to memory, right? This cycle is repeated continuously, millions or billions of times per second, right? Main memory, also called primary memory or random access memory, right? It is the part of the computer that temporarily stores data and instructions that the central processing unit needs right now. Its key point is it is fast, allowing the central processing unit to access data quickly. It is volatile, meaning all data is lost when the computer is turned off, which stores operating system components currently in use, programming that they're running, data being processed, right? In simple explanation, main memory is like computer's active workspace. When you open applications or documents or run programs, They are loaded into main memory, so the central processing can use them instantly, right? Secondary storage is a type of memory that keeps data for a long time, even when the computer is turned off, right? Programs that are used often are saved here and moved into main memory when needed, right? Important files like documents, payroll records, and inventory data are also stored in a secondary storage, right? The most common secondary storage device is the disk drive. It gives us information by magnetically writing it onto a spinning disk, right? There are several kinds of disks, each with its own strengths and weakness, right? Hard disk can store a lot of data and access it quickly, but they are not portable, right? Floppy disk and floppy disk are easy to carry, but hold very small amount of data and are slow. Zip disks are also portable and can store much more than the floppy disk, making them useful for backing up hard drive files. More recently, optical storages such as CDs, which is compact disks, have become popular. Instead of magnetic storage, CDs store data as tiny pieces on the disk surface, right? A laser inside the CD drive reads these pieces to retrieve the information. The CD holds a large amount of data since recoverable CD drives are now common. They are also good for making backups. Therefore, secondary storage, which are used for stored different data or files permanently, right? Input devices used to send information to the computer from outside, right? Which is an input refers to any data the computer receives from outside. The hardware that gathers this data and sends it to the computer is called an input device, right? For example, the keyboard, mouse, scanner, webcam, microphone, trackball, graphic table, optical mark reader, touchpad, joystick, digital camera are all input devices. Those devices like disk drive and CD drive can also act as input devices because they read programs and data and load them into the computer's memory, right? Output devices are used to send information from the computer to the outside, right? That is, the information the computer delivers to the outside world, such as reports, lists, or images, right? This information is sent to an output devices, which displays or produces it. Common output devices include monitor, speaker, projector, plotter, printer, and earphones, right? Output on a monitor is called soft copy, while printed output is known as hard copy, right? Devices like disk drives and CD burners can also act as output devices, right? Because the computer sends data to them for storage. So let's see the software programs that run on a computer. What does software mean? Why we need software? Software is a set of instructions or programs that tell the hardware what to do and how to do it. It is intangible but essential for operations, right? Basically, there are two types of softwares, such as system software and application software. The system software programs that manage the computer hardware and the programs that run on the computer. Basically, there are three types of system softwares. The operating system, which is helpful to control operations of a computer, to manage connected devices, to run programs. The second types of system softwares are utility programs. which is used to support programs that enhance computer operations, right? For example, antivirus software, data backup software, data compression software. The third types of system softwares are software development tools, which are used by programmers to create softwares. For example, we can use compilers, integrated development environments, right? The second types of software is an application software. This is the type of software which is designed to help user perform a specific task, right? When we see to programs and programming languages, as we have discussed earlier, a program is a collection of instructions written in a programming language that tells a computer what actions to perform. These instructions can handle tasks like calculations, data processing, or controlling devices, right? Its main key features are written using a programming language, follows logical step-by-step instructions, can be run by a computer, easy to update or modify, has to be debugged to remove errors, right? While a programming language is the medium of communication between the programmer and the computer. That is a structured way of writing instructions that a computer can understand, right? Basically, there are two types of programming languages, such as low-level languages and high-level languages, right? Low-level languages are easily readable by the machine, and high-level languages are easily readable by the user, right? Basically, there are two types of low-level languages, such as machine language, which is written in binary, that is directly executed by the central processing unit, right? While the assembly language uses symbolic codes instead of a pure binary. Thus, low-level languages are very fast, but it's very difficult to write and understand, right? High-level languages, those are user-friendly languages that are used English-like syntax. They are easier to learn, to read, and maintain, right? For example, C, C++, Python, Java, MATLAB, and so on are types of high-level programming language, high-level language, right? High-level programs must be translated into machine languages using compilers or interpreters, right? Basically, there are three translators in a programming, such as compilers, interpreters, and assemblers, right? Let's see the difference one by one, right? Compiler translates an entire high-level program into machine code all at once, right? The program is then executed after translation. That is fast execution, but slower translation, right? An interpreter translates and executes a high-level program line by line. That is slower execution, but faster testing and debugging, right? An assembler converts assembly language into machine languages, right? Sorry, that is used for low-level hardware-related programming, right? When you write a program in a language like C, C++, or Java, it goes through several steps before it becomes a file the computer can run, right? Therefore, here is from a high-level program to an executable file, right? In the source code, the program you write using a high-level language like C++ programming language. It contains human-readable instructions, right? The preprocessor scans the source code and handles include directives, macros, and conditional combinations. Then it produces modified source code, right? This is the updated code after preprocessing, right? Therefore, in modified source code, all headers, macros, and preprocessors commands have been expanded, right? Then the compiler takes the modified source code and translates it into object code. It checks for syntax error, converts high-level instructions into machine-level instructions, right? Then the object code, which is created in a compiler, is a low-level machine code, but it is not yet complete. The object code, which is created by the compiler, is a low-level machine code, but it is not yet complete because library functions, external references are still missing, right? It is always has an extension of .obj or .o, right? The link combines the object code, library files, and other modules, right? It resolves all external references and joins everything into one file, right? The last one, which is executable code with file extension .exe, the final output is an executable file, which the operating system can run directly. This file contains complete machine code instructions, right? This is how your written program becomes a runnable application. So an algorithm is a set of well-defined instructions designed to solve a specific problem or perform a task. That is, an algorithm is a step-by-step procedure or set of clear instructions designed to solve a specific problem or perform a task, right? A good algorithm should have an input, which is clearly specifies the data it needs to begin. A good algorithm should have an output, which is it must produce at least one result. That is, the output should be clearly defined and meaningful. A good algorithm should have definiteness. That is, every step must be precise, clear, and unambiguous. A good algorithm should have finiteness, which is the algorithm must always finish after a limited number of steps. That is, it should not run endlessly, right? A good algorithm should have effectiveness. That is, each step should be simple and feasible, right? In short, a good algorithm should have clear inputs and outputs, contain definite steps, finish in finite time, and be effective in solving the problems, right? What are the importance of an algorithms? Algorithms are very important because they provide a logical plan before writing a program. That is, they give a clear logical plan before coding, right? They help in problem solving and program design. That is, it assists in solving problems and designing programs efficiently. They make programs easier to understand, to test, and to debug. And it serves as the foundation of programming and competition, right? Simply, algorithms guide programmers to create correct and efficient programs, right? Programs are made of instructions or statements. These are commands that tell the computer what actions to perform. Each statement executes a specific task, right? Programs are made of variables and constants. Variables are named storage locations that can change during programming executions, while constants are named values that do not change while the program runs, right? Programs are made of data types, which are the data types define the kinds of data a variable can hold, such as either integer, float, or character, or string, or boolean, right? Programs are made of operators, which are symbols used to perform operations on data, such as arithmetic operations, relational operations, and logical operations, right? Programs are made of control structures used to control the flow of a program. For example, for decision making, maybe if or switch, loops like for, while loop, and do while loop, and branching, right? Programs are made of functions or procedures, which are blocks of code that perform specific tasks. They make programs modular, reusable, and easier to manage, right? Programs are made of comments. Programs are made of comments, which are non-executable text added to explain the code, right? Programs are made of libraries or modules. Pre-written code. Programs are made of libraries or modules. Pre-written code that can imported to add functionality such as math operation, file handling, or graphics, right? Programs are made of libraries or modules. Pre-written code that can be imported to add functionality such as math operation, file handling, or graphics, right? Simply, a program is made of instructions, data, operations, control flows, reusable functions, explanations, which is a comments, and ready-made libraries or modules, right? That work together to solve any real-world problems, right? Basically, there are three steps that many programs perform. The first one is gather input data, which is using the input devices. The program first collects information needed for processing. The second one is process the input data. That is, the program manipulates or analyzes the input using calculations, logic, or algorithms to produce results. The third one is display the results as output. Right? After processing, the program presents the result on the screen, which is monitor, or on a printer, or saved to a file. Right? In short, programs works in a cycle of input, processing, and output. Right? Creating a program involves several organized steps to ensure it works correctly and efficiently, right? Therefore, here is the complete programming process, right? Before we writing a program or before writing a code, we should define the program's purpose, right? Does it decide what the program should do or identify the problem to be solved and the expected outcomes, right? Then we should visualize the programming running, or we should visualize the program running. Imagine how the program will operate step by step on the computer. This helps foresee potential challenges, right? Then we should design a model of the program using different tools, such as hierarchy charts, which shows program modules and relationships, flow charts, illustrate the flow of logics, or pseudocodes, which is write logic in plain language resembling code, right? Then we should check the model of 4 logical errors. That is, we should review the design to identify and fix mistakes before coding, right? Then we will start write the program source code, right? Translates the model into a programming language. This is the actual code the computer executes, right? Then compile the source code, which converts the high-level code into machine-readable object code, and check for syntax error, right? After that, we should correct compilation errors. Fix any error found during compilation to ensure the code can be translated properly, right? Then link the program. That is, combine object code and library files to create an executable program, right? After that, run the program using test data, right? That is, execute the program which sample input to check its behavior, right? Then correct runtime errors, right? That is, fix any errors that occur while the programming is running, right? Then we should report After that, we should repeat the whole process or the whole cycle as needed, right? Lastly, we should validate the result. That is, check if the program produces the expected output and meets the purpose of defined in step 1, right? Simply, the program process is a cycle of planning, designing, coding, testing, and correcting, right? Repeated until the program works correctly and produces accurate result, right? Thank you so much. If you have any question, you can ask. So, in our next class, we are diving into C++ programming language, one of the most powerful language out there, right? We will learn what C++ is, why C++ is so popular, and even we will start write our first sample program, right?